looks like there's quite a lot going on in this question. We've got a sketch of a curve and we've got its equation right here. There's a function. The first couple of parts look like they're about coordinates, finding A and B, finding Q, so some intercepts and a maximum point. And then part C looks like it's moved on to iteration and change of sign, finding that coordinate of Q. Okay, so let's go one step at a time. First part, find the coordinates of A and of B. Well, those are intercepts with the x-axis. So for part A, we're going to set y equal to 0, or the function equal to 0. So we've got 8 minus x multiplied by ln x equals 0. And if a product equals 0, either the first part is 0 or the second part is 0. Okay, so the first one of those tells us that x equals 8, and the second one, ln x equals 0, means that x is 1. So A must be the point 1, 0, and B must be the point 8, 0. Okay, not very generous, 1 mark for that. Part B, show that the x-coordinate of Q satisfies this mess. And we're told earlier Q is a turning point on this graph. So for a turning point, we want f dash of x equals 0. So we need to differentiate the function f. And if we look at f again, we can see it's a product. It's a product of 8 minus x multiplied by ln x. So we're going to use the product rule when we differentiate it. U dash v minus uv dash. So we've got u as the first function and v is the second one. So u dash v, u dash is minus 1, so minus ln x. That's u dash v. Plus uv dash, so we're going to keep u. V dash ln x differentiates to 1 over x. And for a stationary point, for a turning point, f dash of x equals 0. We said that before. So therefore minus ln x plus, let's expand that bracket, we've got 8 over x minus 1 equals 0 at this point Q that we're trying to find. Okay, and that's an equation. We're not going to solve it. We just have to show that it's equivalent to the equation in the question. So let's move the negative terms over. We've got 8 over x equals 1 plus ln x. That's looking very similar. And I think what we're going to do is some cross multiplying. So the x on the bottom is going to multiply up to the top. And the 1 plus ln x that's on the top currently is going to divide down to the bottom. So therefore 8 over 1 plus ln x equals x. And actually that's exactly what they wanted. So we can just say as required. So we haven't solved that. We don't know where Q is, but we know that its coordinate, its x-coordinate, satisfies that equation. And we can't solve that equation with algebra, which I think is where the next part now makes sense. We're going to do some iteration to try and find the solution to that equation. So let's scroll down. We're trying to solve x equals 8 over 1 plus ln x. Part C, show that the x-coordinate lies between 3.5 and 3.6. That should trigger your thoughts, change of sign. And if you want to do a change of sign, you need a function that equals 0. So for part C, we need to look for a moment at x minus 8 over 1 plus ln x, because that should equal 0. Okay, so we're going to label this function, and can't call it f anymore, let's call it g. This function should have a change of sign. We need to look at g of 3.5 and g of 3.6. So you need to grab a calculator and type in exactly that function. So we need to do 3.5 minus a fraction where we've got 8 on the top and 1 plus ln 3.5 on the bottom. And that's small and negative, that's a good sign, it's negative 0.05, which is less than 0. Then we need to go back and put 3.6 in. and hopefully it will change slightly. It should still be small, but hopefully this time it's going to be positive. And the calculator, I get 0.09, which is very nice. That's small but greater than 0. So we have, let's move down to the next page so we can write it. We have a change of sign. And this function g is continuous, at least on the domain we're looking at, continuous. Therefore, the solution is in the interval 3.5, 3.6. Okay. Part D now sets us up with iteration. We've got an initial value x1, which is 3.5. To work out x2, we substitute 3.5 into that iteration formula. Let's highlight that at the top of the screen. We're substituting 3.5 into there, so we're doing 8 over 1 plus ln 3.5. Remember to use your answer button, so put 3.5 into your calculator, press equals so that that's the current answer, and type in 8 over 1 plus ln answer. And you should get the next two value of 3.551195, and maybe more decimal places as well. Then you can just press equals again, so that was x2. X3 would be the next one, you should probably write these down, 3.5285. X4 is the next one, 3.5385. And the question wants x5, which is the next one, which is 3.5340. That's the one this question wanted. And we have given it to 4 decimal places, which was the accuracy asked for in the question. Okay, part D. Part 2, find the x-coordinate accurate to 2 decimal places. Well, if it looks like we had 3.5, 3.55, 3.52, 5.3, 3.54. It's not completely clear what it is yet, so keep pressing equals on your calculator, writing them down if you've got the patience, or just counting ahead each time you press equals. On my calculator, if I go down a few more steps, they're converging to 3.54 to 2 decimal places. It's 535, which rounds up to 3.54. It's only 1 mark there, so we just need to find that long-term value.